So just like any other language, the Scala 2 has if-else conditions. Okay, so let me just show you. So you could right here. I'm just creating one more notebook for today's session. What's the date today? 7 April and 2018 BDHS. Okay, so you can say Scala. All right, so this is how the simple code looks like. We say, so if followed by an expression, and then this is the block. Unlike Python, this does not have their tab mandatory. In case of Python, when we are writing code in Python, we generally put tabs to mark the blocks. Here you have to start the block with the curly brackets till the end of the curly brackets. Okay, so you can see that here it is printing x is lesser than 20. Okay, it is printing x less than 20. So a question from Mohammed is tab or four spaces. That's correct. In case of Python, that's what is required. Indentation is the word. So either the tab or two spaces or four spaces. Okay. But in here, it doesn't matter. In here, in Scala, it doesn't matter. So we don't have to worry about the indentation much. Okay. Now, so this is how we define the if condition. So if followed by, so we can try experimenting a bit, writing a condition. Let's say x. Okay. So x equals -1. Okay. If x less than 0, right? So we could say print ln and x is less than 0. Okay. So also you notice that if you have multi-line, then you require okay, then you require the block. Like for example here, right? For example here, this one is still being printed. So in case you have multi-lines, okay, so you generally put like this. Okay, if you want to do something here, then if you want multi-lines. Otherwise, let's say if you have just single line of condition, okay, and here we are saying the work is finished. Okay, the work is finished. So this condition will be called, because this will be considered out of the block. Okay, and this will be considered inside the block. We could also write it like this because indentation does not matter much. All right. So basically the sole idea is that either if you have multiple lines to be inside the condition, you put the curly brackets and surround it there. Otherwise, if you have only single expression, then you can just put it in a single line. Okay. So this way your total number of code or the typing efforts are reduced. All right. Now, the next part is, let's say you have the if-else problem, right? If x is greater than 0, we say x is negative, right? Negative. Else print x is positive, right? So something on these lines. Okay, so yeah. Else, all right. Does it require it is mandatory here? If this, okay. Let me just check why it is. All right. So did I make a mistake somewhere? If this, so here we're saying if x is lesser. Actually what we need is probably we need to put curly brackets. Okay. And let's just see if curly bracket works or not. Or does it require? No, semicolon is generally not required in any of the expressions in Scala. Says if x is lesser than this, then print this. This is good, and the curly bracket ends. And here, so something on this line, let me just format it correctly. So it basically the formatting is important because it helps you understand what's wrong with your code. Okay, so you can see that things are okay. If and yeah, this is good, right? Let me see if I can execute this and not this. Okay, so this is correct. And right? Any suggestions at this point? So yes, this looks strange, right? Did I miss a bracket?
Sandeep, when you declare X, right, where is not mentioned before X. Is that
Ah,
the
right.
reason?
Yeah, that's the reason. You're right. You're right. That's exactly the reason. Thank you so much. Okay. All right. That's exactly the reason. Good. Good. So, all right. So, yeah. So now let me just remove the blocks also. So a lot of things could be done without the blocks. Okay. And you don't require even the semicolons. Okay. So let's just see if it works. And right. Wow. Okay. So where equals 5? I think it will require us. No, actually, it does require the blocks. I'm just experimenting with this. Okay. No, it does require the blocks. Okay. So I think the second way of doing it is correct. This is right only, right? If I just remove this, then it won't work. Ah, right. So for if and else to work, you need to put curly brackets. You need to put curly brackets. Okay. So great. So yeah, that's one thing that we learned. Though if condition without the block works fine, but else somehow requires us to put blocks here, right? And what about if I just, so I'm just experimenting with the syntax. So there
Hi,
are
this is
minor,
David. Can you hear me?
yes, I can hear you.
Look at the semicolon on the last print line. It's missing a semicolon, I believe, at the end of
Yes,
the
that's
word
right. That's right.
finish.
So in case of Scala, the semicolon is not generally required. So that's what is as per their language definition. So just like in Python, you don't need to put semicolon. In the same way, Scala also does not require semicolon. I can show you that. So you see, I have removed all the semicolons, and you can see it is working fine. All right. The main problem that I'm trying to figure out is that why does else here, else requires this one to be in the block. The moment we don't put it in the block, it is starts throwing error. All right. So that's an important thing that we learned. Other than that, the blocks are not required. Correct. All right. Great. Great set of inputs. And this is the kind of inputs I'm looking forward from the class. All right. Because that just shows that all of us are involved and we together are trying to understand the language. Okay. Otherwise, it'll basically become one way. All right. So far, any questions? So we have we talked about if conditions and we talked about two parts that we can also put else condition. And the extra thing that we learned today was that we can actually remove the 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 curly brackets from the block if there is only one single line. But in case of else, else generally requires a curly bracket. That's the thing that we learned. Okay, so this is completely okay. And this is also, I'll just put one more block here so that we know what we're talking about. So this is also okay, right? And semicolon is not required. That's another thing that we learned. right? So and here this is the mandatory. If I try to remove this curly bracket, it'll start throwing error. Wonderful. So great. So we learned multiple things. Right? Let's move ahead and we'll see some more expressions. Now, a lot of times we have this if then else conditions, and then inside that we have again another block of if, right? So in that case, we generally require this kind of a syntax. Okay, this kind of a syntax. All right, this kind of a syntax. Okay, so you can see that here we are defining x equals to 30 and then x equals to 10, then the value of right, we are printing the value of x and we are printing that value of x is 10, then 20, then 30. Okay, or should I'll make you right. So let's say we want to print here we want to print say x is even or not, right? So let's say we want to create a syntax such that we want to, let's say x percentage 2 equals 0. So we want to say x is even, right? So x is even, correct? Else if we are saying else if x, right? Else if x equals 1, right? We are saying x is 1, right? And then we are saying x, okay? Then we are saying x percentage 2 equals 1, or we can say x, right? And we are saying 0, okay? We are saying x is divisible by 3, okay? Okay. Finally, we are saying x is not divisible by 3 by 6 and is not 1. Okay, so what we're saying is that if we're first checking x divisible by 2, then we're printing x is even. Otherwise, if that is not true, we are checking if x is 1, right? We are saying x is 1. Else if this, so finally we are printing that. Okay, finally we are printing that value. Right? So let's take a look at it. So here x is even, and right, if we say x is 31, then finally it is saying x is not divisible by 6 and is not 3. Okay, x is not divisible by 2 or 3 and is not 1. Okay, so this we can see quickly. And so there are many advantages of this approach. The advantages of these if else condition is that if first one is checked, then none of this will actually happen. If this condition is true, then none of this will happen. Okay, is everybody comfortable with this syntax? Any questions on this syntax? Should we move ahead? So just like any other language, there's a question from Bintao. Okay, I'll again put it here itself. Okay, so question is okay, question, how should I, okay, all right, so can I make it a little bigger? Okay, never mind, so I think that's good enough. So question is, as of the syntax of if condition, classes, object, etc., what are the differences between Java, Scala, R, and Python in the syntax? Okay, really hard question to answer. Okay, okay. So Okay, so all right, I would yeah. Actually the R part I don't remember so much, but Java, Scala, and Python I am kind of okay. All right, so I can actually give you little um, little input. So I think the differences with Java versus Scala is they are almost same. They're almost same, and the difference between Java versus Scala is number one, the semicolons are not required. All right, required. That's the one. And I don't think there are too much of difference. We'll talk about this. You'll figure out. While if you're coming from Python background versus Scala, right? Um, right. In Scala needs you to put curly brackets, curly brackets, and there are actually yeah, in there are all huge differences in if-else statement. So in Python you have if elif kind of structure, right? If elif kind of structure, not if else. While here we have if else if, right? If else if followed by else, correct? That's the kind of structure we have in Scala. Okay. So there are quite a few differences when it comes to the language, difference between Python and Scala. Okay. The you don't need to put curly brackets. Scala needs you to put curly brackets, and Python wants indentations. Indentations. Okay. So that's the difference. Okay, so I think that would require a bit of more detailed analysis. Okay, that would require. So Sachin, I was trying to answer the question from Binta, and I have typed the same thing here. So I think you've not lost much. Okay, let me. Great, great. So this is what we just learned. And with respect to R, the syntax is very similar to say C or other languages. It should not be much of a difference. Even though the if conditions, else conditions are not much different, but it takes a bit of time to just practice a particular language. And just like you switch between the um, car and a cycle and other vehicles, that there is a bit of difference between different cars. That's the only difference you have with the different languages. Okay, so once you get into that Python mode or Scala mode, you will be able to work in that mode, and you would not have much problem. But it takes a bit of time to get into that mode. And why I'm saying this, because since I have worked with multiple languages from time to time, and therefore there is always time to switch into that language comfort zone. Okay, and right, so in that's right. So like I started with C, C++, then worked with VB, then worked with other languages. So the concepts as such are very same, very much same. There are tiny bit differences. Those differences are what you have to note. And that's why I want to answer this question in more detailed fashion. A good question. Yes, that's another part. Yes. Okay, good. Good. Keep these questions. These are really good questions. A further question from Binta is that, all right, how do you, okay, you can just put the, like this, right? Or should I put double asterisk? Yeah, this is better. Okay, so question is, I believe that there is a difference between this. Okay. So Scala needs you to put curly brackets and Python wants indentation. Okay. So that's what I said, Sachin. Now, okay. Now, a question from Binta is, I believe there's a difference between single quote and double quote. Okay, that's a very important question. So in case of Scala, when we say S equals to Sandeep, right? So the S is basically a string here. S is basically a string. Okay, so to mark strings, you need to put in double quotes. Okay, let's say you want to include double quote in the string, then you will precede it with slash. Okay, if you want to put you want to print slashes in the name, you will put slash like this. Okay, so let's say I want to print C colon. Okay, I want to say C colon and documents, my documents, right? And I would like to put double quotes around the documents here. So this is what I would do. Okay. All right. So this is an interesting example. Do you see that? I wanted to print this, and this is one of my favorite questions that in interviews, that can you just print C colon slash double quote my document slash. Okay, all right. So do you see do you understand why did we put three slashes here? And no? So this one is an escape character for double quotes, because double quotes here means the string has started and a string will be ending with another double quote, right? So this slash basically escapes this double quote, this slash escapes another slash, and this slash escapes this double quote, and this slash escapes another slash, and you're left with this. Okay, so this is what I wanted to print. All right. And this is a common problem when we are accessing file through Scala. We might have to specify this kind of folder structure. Okay. A question from Grisma is that also HDFS uses three codes. Let me just put that here. I think this is a very important question. So yeah. So in that case, basically there, when you are saying HTTP, or let's say you are defining a file path, right? So in case of say string, let's say you're defining a file path. So what you do, you write the protocol name, right? Whenever you want to explain to a system that, hey, I want to access a file. So you put the protocol name followed by colon and double slashes. Okay, then followed by a path. So I'll say this is your protocol, right? Protocol followed by path and so on, right? And I'll just give you an example of what I'm talking about. So I'll just switch between the two things. And okay, so here file slash, here the path could be, in case of any path, it could be either absolute or it could be relative, right? Whenever we are defining path, whether in the local system or any remote system, the path could be either relative or path could be absolute. What's the difference? The relative path begins with a slash. Okay, sorry, the absolute path begins with a slash. In Windows, the absolute path begins with C colon, C colon, right? While in Unix, the absolute path starts with a slash, right? So let's say my username is slash user, and we have folder called slash Sandeep, or or something like that. So this is a standard format: protocol colon double slash followed by the resource path. Okay, and in case let's say we are talking about a URL, right? So how do we define URL? URL is URL is protocol. Protocol could be HTTP, HTTPS, and then followed by double colon slash. Here, note the difference between the slash. Here, the slash is the other slash. This one is this. What do you call? I think this one is called forward slash. This is called backward slash. Okay. So here, HTTP followed by my host name, right? My host name, colon, port number, and then followed by slash, then the path, correct? That's how we generally look at the URL, while the file path goes like this. Okay, so this slash is actually my absolute path. From here, this is the path. Okay, so I hope that makes sense. So here the sole idea was to just to give you an idea of what does it mean by quoting or commenting this, escaping a particular special character. Now in Scala, if you want to define a character, you can define a character using single quote. Okay, you can define a character with a single quote. All right. A question from Muhammad is that how about using the raw string? Yes, you can definitely use the raw string, right? Okay. So I've not yet used raw string with Scala. All right. Okay. So yes. So yeah. So basically, you can also use things like, let's say, um, you want to say print, you could put S character here, and you can say Sandeep, and then use a particular variable in that, right? So you can see that it has printed that particular character. So you can actually uh, have this kind of formatting instead of having to concatenate the names. All right, so we have defined a C and we are saying Sandeep A. This is also called sometimes the string templatization. Okay, a question is, what is the escape character here? You mean in the character?
No, in file path.
In the file path here
Yeah,
in
yeah,
35?
yeah, yeah.
So yes, so here everywhere the slash is an escape character. Okay, so let's say anywhere, right? If I want to print a double quote, I can't really put like this. Why? Because here it is thinking that a string has ended here and there is an extra double quote. So you put a slash before it so that you can print a double quote. You see that? So let's say if you want to print a slash itself, right? If you want to print a slash itself, you put two slashes. Otherwise, if you put slash, it'll give an error. If you see, if you do that, it'll say error, right? Therefore, you need to escape the escape. Okay, so to escape any character, you use slash. Specifically the special characters. Special characters are double quotes and slashes, right? Similar is the case with, say, a character. Okay, so I'll show you this part. So the character here, we could, let's say we want to specify tab, right? We want to specify tab. So we could actually say, all right, I'll show you what is meaning of a tab. So I could say Sandeep and then $C and Giri. So I'm accessing that variable using this kind of a format. Okay, so here, okay. All right, so I'm accessing that particular variable and putting that. So this one is a tab, or a better example would be that I just say print and say C, okay, and say print again and say my surname. And here you can see, all right, so there you go. So here actually it is printing tab, okay, actually it is printing tab. Wow, okay, this is something interesting to know. I see. Actually, it is printing tab. I think this Notepad notebook is kind of skipping it. Okay, so or what else can I demonstrate? So basically, the C means here C equals to /t means these are special characters. This one is for tab, and there is something called, let's say, print new line, right? Print new line. This is /n is for new line, okay, and so on. So basically, this one just prints a new line, okay. And let me show you what it means by new line. So here, okay, wow, this is not working much. All right, I hope this will show you. No, okay, I'll show you something else. Actually, the notebook is kind of removing it because it's a multi-line processor. Anyway, it goes to the next line, and the notebook is eating that up. All right, so the point I was trying to make is that the characters you define using these special values, it's just that I'm not able to print through here, so maybe I can just show you in the console. Okay, I have a console here open. So I could show you that. All right, so let me just show you. Okay, you can see there is a tab here. There's a tab here. Actually, this tab is being eaten by the notebook. Okay, now here it is showing well. So if I have print, let me show you, print this, and then I'm saying print tab, then again here I'm saying print. Okay, so now you'll be able to see there is a tab here. All right, there's a tab here, and that's how it works. All right, so basically the idea of a tab is you basically tabify the output. Tab is generally the 8 characters. Okay, and that's how it works. All right, so this is how we define the strings in characters, strings in double quote, and characters in the single quote. All right, and the numbers and the decimal numbers without any single quote or double quote. And so while in case of, say, other languages like Python, there is single quote and double quote, both are used interchangeably for defining the strings itself, for assigning the strings itself. All right.
Sandeep, one question. This
Yeah,
Scala does not need indentation.
that's
Without
right.
indentation.
That's right. So unlike Python, but more like Java, C, C++, and other languages, it it does not need indentation. You just have to put curly brackets.
Okay, thanks.
Okay. A question from Alok is, I'm running the command to create a Scala project, sbt new hello world, is giving the error, not a valid command, the new one. Okay. All right. All right. It'll be great to take a look at that one. Just give us some time. I will catch up with you till the SBT, and then we'll discuss. All right. Great. Great. Wonderful. Wonderful. All right. Just okay. Sure. I'll share with you the. For now, let me just share you the Google Docs so that okay. Okay. I think you will be able to copy paste from this notebook. Are you able to copy paste from this presentation? Others can confirm who have access to that. Okay. Rajan is able to copy paste from this URL? No. This document. Let me just open this in anonymous window. I've opened it in the incognito window, and there. Let me see. Yeah, I am able to copy. I'm able to select. Let's say this piece of code I want to select, and I should be able to paste it here. Yeah, I'm able to paste. Okay, so yes, you should be able to do that. All right, great. So please use that. Now, so there's a bit of difference between the loops in between other languages and Scala. Okay, so specifically the for loop is something a little different. So we'll have to pay attention to it. So while loop repeats a statement or group of statements while a given condition is true. It tests the conditions before executing the loop body. Now, what then on the other hand, we have do while loop. It's actually very much same as like while statement, but the first execution happens for all. The first execution happens for all, and it tests the conditions after the work is done. After the work is done, the block is executed. Then the third one is the for loop. The for loop executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. Okay, this looks like a little, you know, uh, a sentence that doesn't make sense, but it'll make sense when you see the example. So for loop is a definite loop. So for loop or for statement is basically for going through a list. Going through a list. Okay, let me just show you. So here the while loop is very clear. We are starting with a equals to 10. Then while a is less than 20, right? A is less than 20, print the value of a. Okay, print the value of a. So here you can see the body of this one. Okay, all right. Should I okay, this is good. So here what we are saying that keep on while the loop. Okay, so what is that, Binta? Okay, all right. I hope. Okay, so all right. So here we have right. So we are starting with a equals 10, then we are looping up to or less than 20, and then we are printing the value of a, and this is how it looks like. Right. So I changed the name of this book, right? No. Okay, now it looks good. So this one is clear to everyone. So we are starting with A as 10 and we are executing this condition until A is 20. Moving ahead. Now, this one is a do while loop. Here, this will happen inevitably. Okay, this will happen no matter whether A is less than 20 or not. So you can see here also basically the same thing. So we're printing the value of A. So starting with here. And this will basically, if the value of A is 20, this will execute at least once. Okay, this will execute at least once. So the while loop and do while loop, both of them are indefinite. Okay, and if let's say previous one, if you're executing with A equals to 20, then the result is that it won't do anything. It won't print anything. Okay, so basically you can see the difference between while and do while. In do while, this will be executed first and checking will happen later. Okay, this do while is good if we have initialization code that we want to execute first before checking the condition. Okay, before we check the condition, like uh, let's say first we load something, then we check, then we load something else. In those cases we generally prefer the do while. Okay, specifically um, let's say there is a function called access URL, right? There's a function called access URL, and access URL, okay, or let's say there is a function called load URL. Load URL, it returns us two values. Imagine that it is returning us, say, data, right? An object. So let's say while data dot has next. Okay, I'm just making up a hypothetical um, condition. Okay, has next. Okay, and we are saying data equals load URL, right? And we are calling, say, uh, data dot save to disk. Okay, I'm just making up a very simple example for you. So imagine that you are loading some data from a URL. Actually, this is something which I was doing day before yesterday, and I realized that I could actually use the do while loop instead of while loop. Okay, specifically with respect to some work where we were loading the URL. URL was returning the value of, like, if there are more data left on this, there are pagination, like there are more pages left of the data, right? So basically this is the kind of thing. So here I'm just no I'm these are all made up functions. Let's say there is a load URL and data has a save method, data has next. So what you see is that in this case we are loading the URL, saving to the disk, checking it, and then again doing it, right? So instead of such kind of a code, we could actually do the other way, right? We could do, say, do and say while and say data dot has next, right? And call these two functions. So which code looks better, the 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 code here or code above? All right, so this is a good example of say, let's say you're loading the data and data has many pages. So when you're loading it here and going to the next page, so we say here like load URL page equals 1, and every time we are basically, after this, we are increasing page by 1, right? So now does it make sense to you? So there is what I'm trying to explain is if let's say page equals to 1 and we are increasing page by 1, right? Page plus equals to 1, and then we're doing the same thing again over and over. So this one is with the while. Yes, you have something to say. Somebody has unmute.
Hi,
Muhammad?
Sandeep.
Yeah,
Yeah,
go ahead, please.
I have a question.
Mm-hmm.
So for once when I had gone for an interview,
Mm-hmm.
they asked me like for and while nearly does the same thing.
In what kind of interview was it?
It was like a Python developer position.
Okay. Okay.
So they asked me like in which cases would you use for and in which cases would you use while. So they
Wonderful question.
asked me like for a specific use case and I couldn't answer. Can you please help me
Okay.
with the
Yes, I'll do that. So the same thing what I'm doing with while right now, do and do while and while, the same analysis we'll do for the for loop, and that would
Okay.
help you.
Thank you so
Okay.
much.
All right. All right. So I hope this is clear to everybody. So you see the difference here. This piece of code is repeated twice. Okay, here this initialization is same for all, and let's say right here in the imagine that we have the let's say http slash google or slash, let's say my site and my site.com slash, and we have say page. Okay, so you can see that. So this is the kind of we are loading let's say we are downloading data from somewhere, right? This is what we're going to do. Correct. So I'm going to make it extremely simple for you to visualize, right? So these are the two examples of the code. One is example one. Okay, and this is the example two. Okay, this is the example two. Now, which one do you think looks neater? The example two or while the second one? Which one do you think looks good? This one, or this one? Second one, right? So why? Because to know whether the data has next page or not, we need to first get the data, correct? That's why we need to execute the condition first and then check later, right? So this kind of pattern where you need to do something mandatorily and then check whether to do it again or not. In those cases, we need do while loop. Okay, the while loop, the while loop is the default way. When you start doing something, you pick up the while loop first. If you feel that okay, my code is being repeated, my code, you can see here clearly this code, these three lines are kind of repeated. We loaded the data first, then we did the condition check, and then we did the same thing again. Okay, all right, wonderful. So this was example of this is something that I just faced. I could actually show you the code, and all right. So this was, but that was in I think other language. All right. So everybody is clear about while and do while. Do while does the same thing as while, just that it makes the code cleaner. Sometimes it might look good. A question from Grishma is, do while just saves one loop of checking, right? Not really. Not really. It will do the equal amount of checking. The whole conditions, the time taken will be the same in case of do while as well as while. The time taken, just the coding effort. Here you can see this piece of code we had to write twice. Correct? This piece of code we had to write twice. All right. And say if we realize, oh, the spelling of my site is wrong, so we'll have to change here as well as here. While in this second example, we just have to change it one place. More number of lines are harder to manage. So you generally need to keep your code cleaner so that you have smallest number of lines. Okay, that does not mean that you put everything in the same line. When I say line, it means the expressions. Okay, and we should not cut down the line just to avoid number of lines. We should cut down the line to make the code really simple. Okay, so this code looks more intuitive, while this code here looks, oh, there is something going on. There's the why we are doing it again, why we are writing this code again. Yes, if the code is bigger, if the code is big, the chance of the code being buggy is too high, and so whenever you sense a thing that you're writing a while loop and we were doing the same thing inside the loop, what we just did before the loop, then that means that there is a need of re restructuring your logic into do while. Okay, now moving ahead, I hope this is clear to all. No? So here I just made up an example where we are loading data from a URL, saving it to the disk, and then this URL requires a page number. So we are increasing the page number and just checking if the data has next, then we are doing the same thing again. Yes, you had a question, Sachin?
Yes, Sandeep. So it
Yes,
means in do while the difference is at least the code will execute once, whatever you put in the do. But in the
Cor-
while, it is not executed if the condition fails.
correct, correct.
So this is a difference.
Yes, this is a difference.
Okay.
Okay, great, great. I hope this is clear to all, everyone. All right, so yeah, I'm moving ahead now. Now, there is this difference from the Java, right? In Java, the for loop was very different, but in Scala, the inspiration comes from Python and other languages. And the sole idea here is that to distinguish between uh, two kind of loops, right? There are two kind of loops. One, indefinite loops, and other called definite loops. Okay, so indefinite loops. Okay, so here again, the difference is, all right. So definite uh, loops are for, and indefinite are while, right? And do while. So when I say definite, it doesn't mean that it's it doesn't mean that it is always going into the loop. Okay, it essentially means that, okay, so this while loop or do while loop that we saw above, right? Here, if we make a mistake in the condition, or let's say there was a mistake bug in the API, there is a chance that we will inevitably end up with an infinite loop. We will inevitably end up in infinite loop. Okay, I'll show you. So let's say we want to print all the numbers from 10 to 1. Okay, so what we are doing is we are writing a equals, say, 10, and we have written a while a not equal to 0, right? And this is a dangerous thing what I'm doing. Okay, so println, and I say a. Okay, and I say a minus equal to 1, right? This looks really innocent code, right? This looks innocent code, correct? Do you think there is a bug in this that could make it go in the infinite loop? Okay. A question from David, a point from David is that for loop is when you know the number of items to go through the loops. That's right. For loop we use when we want to go through the list of items. In contrast to the while is used when you're waiting for something to happen. While is when we want to check a condition and then do something. Do while is we do something and then check the condition. While for loop is for enumeration or for iterating over the list. Okay. This will become very clear after this discussion. So you can see that we are iterating here, but there's a danger around here. If I put, let's say, if I put -1, do you think it'll go in infinite loop? That's right. So, or let's say I forgot to put this condition properly, and I kind of missed this condition, right? Then also this loop will become infinite loop. Okay, this loop will become infinite loop. I can just show you this, but my notebook will hang. So I'm going to do it in the terminal because I can kill the terminal very quickly. Okay. All right, I'm again typing the same thing. Okay, so I'll say var. Okay, not here, not here. Okay, right, it's going in the infinite loop. You can see that. Okay, so no matter how good an engineer I am, there is always a chance that I would make mistake in the code and it would end up in the infinite loop, right? Therefore, the Python recognized that need and came up with something called definite loop, and that for loop is a definite loop. So in the same is in case of Scala. If I want to just iterate over if I want to just iterate over a list of items, I could say 1 to 10 and say print. Okay, so you can see that it basically printed. There is no chance that I could make it run indefinitely. Okay, so here I'm saying that 1 to 10, 1 to 10 means it generates a list of items. It generates a range of items. You can see that. So we are saying that for I or I could just say myself here. So I could say list 1, 5, 6, and 7. Right? So you can see that it has basically gone through the list. So for loop is a definite loop. Okay, for loop is a definite loop where we have list of items and we want to go through that. While while the while loop or do while loop are indefinite loops. There is a chance that you will get stuck in an infinite loop. Okay, so that's the difference between the for and the while. This is where with respect to for loop, the Python and Scala are same, and Scala and Java are different with respect to the for loop. In case of Java, for loop was basically just another while loop, right? For loop has initialization condition. If you guys remember, this is from Java. This is how it looked. Or C also had the same kind of construct, and less than 10, I plus plus, and then we say things like that. Okay, so this is double slashes. Double slashes are for comments. Okay, so this way, so we could just say print I. So it says that this is not found. Okay, so basically, all right. So in Java, this was the syntax. It was nothing but different Java or C, actually C++. The for loop was this. Okay, for loop was this, and that's where the difference was. That's where the difference was. Oh, it is formatting it wrong. I'll just indent it so that it formats like, okay. And I could actually say, all right. So this is how it was in case of Java, C or C++. While in case of this is the cases of similar thing happens in Python also. Okay, so you can see that in Scala you can actually just go through the list of items. That's right. Um, so you can see that we never initialized A in the loop, correct? So A is basically initialized in the for loops body. Okay, we never defined where a equals something. So for automatically did that. That's a loop variable. Yeah, go
Sandeep, I
ahead.
have a question. In the for
Yes.
loop, you said we never initialize. So in the list, the minimum value, how will we know what is the min? So because we have taken the less than symbol, is it like the minimum value assigned is one
Uh,
initial?
so so basically the for loop here in case of Scala is about iterating the list. Okay. So it is basically if you have a list of item or range, the range is a proper term. Okay. So if we have anything iterable and we want to go through that list, we would use for loop.
Okay, it's not like
Okay.
in Java we.
Correct, correct. In Java, you have to define int I equals to 0, I less than, like that, right? The one
Yes,
that I've given you example.
yes,
So this is where it is different from Java, but similar to Python. Okay, so I can say that in Scala, the for loop is similar to Python, but different from different from Java. Can you, is it okay to mute now?
yeah, yeah.
Is- All right, great. So this is what I'm writing in the markdown. Okay, so some of the shells you can actually make them markdown either by using cell and cell type as markdown or just press escape and put M. That way you can make it markdown. All right, so great. Thank you, Mohammed. Question from Sachin is if it is not the list, if it is a range, then it will work in the same way. If it is not the list, no, it won't work in the same way. We just showed you that it gave you an error that this is an invalid syntax, correct? In for loop, how would you decrement by one? That's right. Thank you, Mohammed. So we can do that, or or I think if I say 10 to 1, does it work? I think it does. Okay, it doesn't work. 10 to 1. All right, so this is the way you can do. All right, thank you. So basically, if we want to say go from 10 to 1, we could just say, okay. A question from Inta is there a semicolon required at the end of every statement in Scala or Java? In Java, the semicolon is required, but in Scala and Python, not required. Okay. With respect to semicolon, as well as for loop, the Scala and the Python are same. Semicolon is not required. All right. Let me just change cell type back to the code. So great. So we were able to understand the difference between for loop. Mohammed, is your question answered with respect to for loop and while loop? Okay. So if you have a list of things to iterate over, prefer to iterate using for loop. Don't use while loop. Okay, because even though we think that nothing is going to happen, trust me, a lot of times actually we end up in the infinite loop. Okay, so uh, even I end up in infinite loop many times. Okay, so it's better to have cleaner code using the, if we have, let's say, a list of things and we want to iterate over, just use the for loop instead of using the while loop. Okay, although whatever for loop does, we can get it done with while loop. Similarly, we can get everything done with a while loop using so whether the work of for loop or do while loop, we can get everything done using a single while loop. Okay, and when the languages are generally implemented, one bootstrap method is created, and using that method, the rest of the language is implemented. So yeah, that's a little digression. I'll avoid going that direction. Okay, now, so till now, what we talked about is the basics of Scala. We talked about the variable declarations and the strings and the data types and the if conditions and loops. So conditions and loops and declarations. All right, few questions. So would you say for is safer than while? Correct. I would say that, and also cleaner than while. Okay, because you have to define the loop variable and then iterate over, check the condition and so on. So if you have a list, then use for loop over to iterate over it, not the while loop. If you have a complex, if you have a condition to check and then do something, then use while loop. Now, Sachin's question is, how do we I++ or I minus minus in Scala? So here, I have not seen the syntax of I++. So let's say I equals to 1, and you want to increase this by 1, you could just say I plus equals 1. Okay, this kind of syntax I don't think it's valid here. So they have done away with plus plus or minus minus kind of syntax of C++, okay, in Scala. All right, so just like in same thing is in case of Python, they also did not use plus plus and minus minus kind of thing. All right. Okay, question from Prasant is, do we have Lambda function in Scala? Yes, Scala is designed for Lambda functions. I'm going to talk about that next. I'm going to want to spend more time there. Okay, and I mean in loop for, okay, great. So, all right, so this were the basics. Now come the very interesting part called defining a function, right?
I mean that in the for loop, like in Java, for example, we use for I is equal to 0, I plus 1.
Right, right,
So
right.
how we increment the value of I in Scala?
Right. So we generally increment using I plus equals 1.
Outside of the loop we put, or we put
Okay. So in that case, let's say you want to increment, and let's say you are using this. Okay. What you mean is probably what I'm going to show you here. Let's say you are iterating. Let's say you are iterating over the list from 1 to 10, correct? And at the same time, you would like to keep a counter of things. Let's say I am having count even numbers, right? Count evens. And let's say initially count evens is 0. And here what I've done is if a percentage 2 equals 0, that means it's an even. Percent means divide, and whatever is the remainder is returned by this expression. Okay, so here what we are doing is you can just check things quickly, that this is something that I want to show you. So 5% 2, right? What's the value? 1, right? And 6% 2 is 0. I mean, this returns us the remainder. So we are saying divide a by 2, and if the value is 0, that means increment the count evens, right? So we'll say this, and at the end of it all, we could say print ln count evens, right? Count. Okay, it isn't autocomplete, or maybe there's a mistake in this. So you can see that it has right. I'll just print here, or I could just say print ln, and I could use the string format method of printing things. Okay, so this is also really cool thing about Scala, that you could print a string just like this. Okay, so you can see counts of events, right? So there are 5 events that we have encountered while going through the list. Is that your question?
yeah. So by -1 reduced by -1 value.
That's right.
Yeah. Okay.
Okay,
Yeah. Thanks.
great. All right. So if you want to jump through that, All right. One thing I would like to discuss here, if you guys are ready, that would actually, I'll just close this. So that's something that you would need when you are going for, say, any kind of interview. It's called the complexity of your program. Okay, this is something I'm taking a little deviation. And why I'm taking this deviation is because a lot of us have forgotten that part. And in the discussions, when you go anywhere, people kind of assume that you would know these values, these things. And so I would like to just take a bit of digression. I hope that's okay. There's something called there's something called complexity, right? Complexity, or we call it big O notation, right? I'll just touch upon it. I hope others are not right. Others are okay with this. All right. So because this is something I found that over and over again, when you go to interview and people ask you a question like things like big O notation, and you think that even though it's a very commonsensical thing, but just because you don't know the term, it looks really strange. Okay. Right. Even though in the practical IT world, we don't use this, but in case of data science and machine learning kind of profiles, you would be asked these parts. Okay, so I'm going to just take a bit of digression. Those who know already would also learn few of the things from this. Okay, so when it comes to, say, algorithms or data structures or any code, any program that we write, we generally don't count the number of times statements are executed. Okay, not exactly. Like for example, here let's say this loop, right? Let me ask you, how many times print will get executed? Quickly. So this instruction, right? 10 times, correct? But can I ask you that how many milliseconds will it take? You can't answer that, right? So instead of counting exact milliseconds, exact number of statement, we generally measure or keep a track of what is the impact of increasing the number of elements on our output. What is the impact of increasing number of elements in the input on our program, right? So yes. So thank you, Mohammed. Mohammed's question is that Python has a package has a fine time of execution. Actually, in case of notebook itself, in Python you could just put time and it would show you the time. Okay, so here the time is not there yet in this notebook in Scala, but in others it is there. Okay, even you can check that. That's right. But the question here is that if we look at a program and say that, okay, this one will take more time, this one will take less time, right? So that's not generally a correct way of doing it. Correct way is actually, right way is just count the total statements in your program and then report that these many statements will be executed exactly, and hence this much time will be taken. But in theoretical computer science, what happens is before your program is working, let's say you run the program and it's not finishing at all, it's taking like a couple of days, right? So you don't really have a time that right, how much time would it take? So you don't have an expectation, right? So that's where the complexity comes. So what we do is, instead of counting exact number of statement, what we say is we will say something called our output is proportional to the input size. Okay, okay, what is the our output is proportional in what way? Okay, what way? I'll ask you this question. So let's say we have n elements, right? And we are let's say iterating twice here. Okay, so all right, let me just say, let's say we are taking the input, int n is our input. Okay, and I'm saying not n, where n equals 10, and we are saying uh, go this way, and also write another loop here inside this. Okay, or here there is a while loop, and there we are doing something, or let me just put it this way. Okay, okay, so right, print. So we are going to print A and B. Okay, so this one generates all possible combinations of the values. Okay, so this is supposed to be double slash, right? So it's generating all combinations of all the elements from this. Now question is, how many statements are there in this code? Okay, so there are n into n, right? N into n. The total number of times println is getting executed in n into n. So we, instead of exactly counting the statement, we say that our complexity of the program is n into n. Okay, our the complexity of our program is how much? N square. All right. Okay, so that also means that if our program is taking n square plus 20 statements, we will only report it as n square. So whenever we look at the code, we generally look at how many iterations and how many loops are there, and how many times these loops would get executed, and we just report that in what way. Instead of saying it'll take n square plus 23, n square plus 5, we just say that okay, our complexity is n square, or we call it capital O of n square, right? Is this clear to everybody? It's just a terminology. We have a hunch that this program is going to run every time n times for every n elements. That means it's going to be n plus n up to n times. That means it is going to be n square, right? And you can see that. Okay, you can see that. And if you want to check, okay. A question from Jay is, could you, right? All right, let me also explain this sentence. Okay, here when you want to format a string in Scala, you could put small s in front of the string, and then all the variables of this class you could use with dollar. Okay, okay. And how about small r and capital S? I'll have to take a look. I'm not quite used to the small r and capital S. Probably r would be either for the raw or for the regular expression. I'll have to take a look. Okay, so all right. Great, great. Now the next question from Jay is, could you explain with another example? Let me just come up with another one. All right. Right. Let's say what we are doing is okay. Let me. Okay. So let's say we are okay. Right, right, right. So okay, let me just give it a thought. Let me just write a while loop and that'll make more sense to you. So let me just iterate very simply, say where n equals 10 while n is greater than 0. Okay, we are saying print n, right? ln n, and we are saying n minus equals to 1. Okay, so what's the complexity of this one? What's the complexity? How many times the loop will run? 10 times, right? So if we increase the total number of input variables to 2x, so if we increase this n by 2x, meaning twice, the number of times the print will get executed, or the number of times these statements will get executed, will become twice. That means the total number of time taken by your program is linearly proportional to the number of input elements. Okay, this sentence is far more important to us. So as we increase n, the output time overall time which is going to be taken is linearly proportional. Linearly proportional. Okay, now let me ask you a little more difficult question. So imagine that we have n,000, right? And we say that n divided by equal to 2. And we here saying that as long as n is greater than 1, let this loop be executed. My question to all of you is, okay, let me just keep it a separate code. Okay, so here I'm saying n minus equal to 1. And okay, so all right, let me just create a couple of more examples. So this one has the complexity of on, right? So this one has the complexity of on, and this one has complexity of, let's say, n by 2, right? So how many times? Anybody? So what's the complexity of this one? As long as, no, this one, the one where I am. Okay, ouch, this one went, see, okay, and right, so this one, the one where I'm decreasing n by 2, right? And by every time we are decreasing n by 2, imagine that it was, say, 20, so it'll run for 10 times, right? So the big O notation is n by 2. So the complexity of this one is O n by 2. And generally O n by 2 is also kind of considered in the same bracket as O n. Okay, it's linearly dependent. Okay, so this is clear. Now the next question, what is the complexity of this one? Here, every time we are dividing n by 2, right? So that means that if this statement gets executed by m number of times, imagine that m times the statement is executed, then 2 to the power m, because every time we are making it half, that means opposite is also true. So every time we if we start from 1 and keep on powering it up to this should be equal to n, and therefore the complexity is log base 2 of n, right? So m equals log base 2 of n. So you can see that. So this statement is going to be executed those many times. Okay, so here the complexity is, we call this complexity as log m. Okay, log n, sorry, log n. Is it clear? Yes, everyone? I can explain it again. So if there are n statements in this, so the input number n is say 1,000, right? So this statement runs really fast. I can show you this. This statement runs really fast. Okay, here. Okay, you see that? It's so quickly converged. So every time it becomes half. That's right, Jay. So the wonderful idea about this particular thing is that let's say you have a humongous database table. Okay, let me show you, ask you this very simple question. Let's say, you have a humongous table. Okay, humongous table, and it has index. Okay, so searching in the index is same complexity as this one, because when we are searching, so we jump into mid and then go to the left half or right half. Every time the total number of elements that we are going to look for become half. So its complexity is searching in is log n. Okay, log n, right? So now if there were 1,000 records, and time was, or let me just make it a little simpler, 1,024 records, and the time taken was 5 seconds, right? And if there are the 1,024 into 1,024, right? What will be the time taken? Time taking, let's say there was a database table which has 1,000 records, and the time taken was 5 seconds, right? Here the time taken was 5 seconds, and if you increase the records to million records, if we increase the record by 1,000,000, then my question to all of you is that what will be the time taken? How much? Correct? So again, there was a humongous table on which we created index. Creating index means extracting the keywords from the column and ordering them, putting them in an ordered list, and that's called an index. And when we are searching in that index, in that list of things, we are using a binary search, meaning we jump to the mid, check if we have our if the element that we're looking for is on the right or the left, then we go to the left or the right accordingly. So that's called binary search. So that one generally takes the complexity of searching is around O log n. So if there are 1,024 records and the time taken to search a particular record was 5 seconds, and if there are now 1,000,000 records, what will be the time taken? So, okay, I'll explain. So how much is log of 1024? Log base 2. 10, right? And log base 2, 1024 into 1024, 20, right? Right? So basically the time taken would actually just become 10 seconds. I'll talk about that, Binta. So does it sound like magical to you that for 1,000 records it was taking 5 seconds, and for 1,000,000 records it's taking 10 seconds? All right. Okay. So n square, when you log it, do the log, and I'll explain to you. Imagine that time taken was equal to some constant into log of number of records, right? So how much is this constant? K equals to how much? 0.5, right? And now the time taken will be 0.5 into log of 1024 plus log of 1024, right? Because when you multiply two things in the logarithm, you get this. Okay, so you will get 10 seconds. So whenever we are doing the log, the things are basically getting added instead of getting multiplied. So it sounds very strange and very unreasonable, but this is true, and that's why a lot of DBAs get paid really well, because they figure out that we can convert the table into the indexes, and therefore they can reduce the time drastically. Okay, so whenever I say that I have increased the performance by 500,000 times, it's actually a minor tweak. Okay, I so well remember in many cases where I was able to bring down the time taken to by multitudes. You can see that multitudes, had there been no index, the time could have been here 5,000 times. Okay, so time could have been 1,000 times, right? So that way. Okay. So a question from Mohammed is, can you talk about indexing really quick? If you want, I can go ahead, because this course is about big data. I can, yeah, quickly go ahead. All right. Is everybody okay? Because we are on the loops and this course is about big data. I can actually explain to you. Oh, we forgot the break. All right, so let's take a break for 10 minutes. All right.
Sandeep, one
So,
question, like the complexity which we have taken like ON, it is
right.
the unit is second, or it is time unit, or it has no unit?
No unit. It is basically saying that whatever is the time, it's proportional to number of elements.
Okay. And if we want to calculate the time, then we can use the time function.
If we, yeah, yeah. If we want to, because it's impossible theoretically to compute the time. Okay.
Why?
That's why while looking at a program, we generally don't talk about how much time will it take. Instead, we talk about what is the complexity, or how is time dependent? How is the time dependent on the input number of elements? Okay,
Okay.
so yeah, because we can't say that our time is dependent on the processor, because it of course time is dependent on processor, but that's not a property of our program. Our program's property is that what kind of input can it handle, what kind of data, how big the data can it handle, and how much time is what kind of expectation should I have. Okay, and yeah, that's the one I was talking about.
Okay.
Okay, right. There was a question regarding the indexing. Okay, so I could actually draw it and then show it. I think that'll be okay. All right. So right here, what you see is right. So what you see here is, let's say there is a list, there is a list which contains some numbers 1, 2, 3, 4, 5, 6, right? And if we have to find a particular number, let's say I'm defining a list here. Okay, I'm defining a list here, and I have to say find our target number called target equals okay, just ignore this piece of code. I'll talk about this later. And we're looking for some element called 5, right? We want to find out at what index does this 5 exist in the list. How would I find out? I'll say while, or I could simply say for a in list, correct? And if the target uh, equals to a, then I print found. Okay, I print found. That's all right. And there is no break statement in this, so we'll have to import something called breakable, and only then we'll be able to exit from it. Okay, we'll talk about that very soon. We'll use the return statement instead of this. Okay, so all right, so you can see found the element, right? So what is the complexity of this program? What is the the worst case scenario? How many steps will it take if there are n, right? So it's a linear search. It's basically scanning through the list O of n, right? And if you were doing the linear search in the above example here, instead of the indexing, it would take 5,000 times, correct? 5,000 seconds for a million record. If it was taking 5 seconds for 1,000 records. All right. So the complexity of this one is, the complexity is ON, right? So that's the complexity of the program. All right, can you, yeah, could you mute? Yeah, I muted, no worries. Right, so is this clear to everyone? So let's say you have a database table that contains these many rows. And if you're looking for a particular row, right? So this is equivalent of saying select star from table where target, where a column value A equals target, right? That's what we do in case of databases. We are going through the table element by element and checking whether a particular element is found or not. So this one is called scanning. It's a linear scanning of the data. This one has, if for 1,000 records it takes 5 seconds, right? For 1 million records, it would take 5,000 seconds, right? This is the standard, right? So when right. So if it was taking for 1,000 records, it was taking 5 seconds, and 1 million is taking 5,000 seconds, right? Now, question is, this is worst case scenario. Yes, we always talk about, whenever we talk about big O complexity, there are two things. One is average time complexity. Other is called the the worst case scenario, worst time complexity. So we generally, when we are optimizing, we generally work with the worst case scenario, because 5 could exist here, or maybe at the list, or maybe we are looking for, say, target equals 10. Okay, so we generally work with the worst case scenario instead of the average. Sometimes we do look at the average, but yeah. All right, is it making sense to you? So this is basically the complexity of this one. Now, imagine that, okay, this one is great because this one can actually, if the here or so on. Now, if we could just order these elements, if we could just order these elements in once, if we just order these elements once, then the searching would become really, really fast. Like the way we prepare the word index on the back of the book, or so what we'll do is we will order these and create a separate list. We'll order these and create a separate list. Okay. So we'll order this, let's call it list underscore index. And for time being, we'll just order manually. Okay. So 10 will go to the end, right? And this 3 would come to the middle. So now this data is ordered. Did I do? Okay, this data is ordered. All right. So this is how the list index looks like. So this is separate list, okay, in which we will also will keeping the extra information. Instead of keeping numbers here, we'll create an object where first value is this, second value is the index of the original list. So this is generally called the index. Same is in the case of databases. If this list is list of rows, then this list is the index. Okay, it is keeping the values, and values are having a pointer to the actual one, right? So in this, what we generally do is we do something called a binary search. I've written a very rudimentary code. I'm not sure if it is going to work or not. Okay, so all right. So I'm just going to write found equals -1, and here I'm saying found equals made, and I'm saying found equals made. So all right. So here I'll say, okay. All right. So I'm just going to walk you through this piece of code. Okay. So I'll just show you. Found at. Okay. Right. So yes. And the target here, this target we have already defined as, let's say target is this. Okay, let's say target is 8. Okay, now, so since it was very, very inefficient here, you can see, okay, so what is it that we're talking about? We're talking about finding something in a list of things. We are trying to find something in the list of things. Now, these things could be rows in a database table. These things could be values in a big text file. These things could be anything, right? So one way is we go from left to right, keep comparing what we are looking for, and when we get, we stop. This approach is great. This approach is great, but it is not very efficient. Okay, so if you are just searching once, then this approach is wonderful. But if you know that thousands of times this search is going to happen for the elements on this table, so we will, and there are going to be lots and lots of elements, and we don't want to spend so much time in searching. So what we do is we will keep things in order and do a binary search. And how does binary search work? Let's say we're looking for 8. The way binary search work is we go to the middle and compare whether this element is lesser than or greater than 8. Since it is lesser than, therefore we only search to the right. Okay, to the right, as in then we compare in the middle of this part, which is 10. That means this is greater than 8, therefore it will be on the left hand side. So we search only in these two elements, and then in the next one we will find the results. Let's say we are looking for, say, 3. So what we'll do is we'll go to the middle of the list. We'll go to the middle of list. Let's say this is the middle of list, right? 5. So we compare this, and we know that this data is ordered. This index is ordered. Index is nothing but ordered list of things, right? So we compare 3 with 5 and see, okay, this 5 is greater than 3. So we go to the left and search again to the only in the left part. So again, go to the middle one and find it there. So, and that's what it is. So we basically keep on doing that. And that's the code I've written here. I've written like we start with left equals 0 and right equals this. Okay. And as long as left is lesser than right, we find the middle value. And if middle equals to target, we say found equals this. And otherwise, if the list, the middle value is greater than target, then we go to the right or the left. Okay, this is not right. Yeah, we do that. So here we see if the middle is equal to left plus right, right minus left by 2, as in we are basically saying left plus right by 2. Okay, and why are we doing this way? Not saying left plus anybody right by 2. Okay, you see this value, instead of this we are saying this expression. Okay, I hope you are not joining out. So okay, feel free to ask questions, because these are the things I'm expecting a lot of questions from you. Okay, so probably the question you have in mind is the question others are having, just that they're not articulating. Okay, so what we are doing is we are jumping to the middle of any list and checking whether to retain the right one or to retain the left one, or to skip the left one or to skip the right one. That's what we are deciding here. Okay, so here if the middle element is greater than what we are looking for, so what we do is if let's say the list, the middle of the list that we jumped at, let's say we're looking for 3 and uh, okay, so we're looking for this and we're comparing here. So we'll come here saying that okay, middle is, so we'll compare here. So middle is greater than target, correct? Middle is 5 and we're looking for 3. So what will happen is right will be equal to 1 less than the middle. That means only this part. Left will remain as such. Okay, and in the next round it will find the value. Okay, does this code make sense to you? This is exactly what we have done so far. There is one extra component here. We have put ampersand ampersand. Ampersand ampersand means and condition. The condition is generally like this. We are saying found equals -1, meaning like when we say 2 equals 3, it would return true or false, right? True or false. And so on. A question is, why are we using dollar? Is basically a way to format a string like printf. Okay, instead of saying %s, we are referring to the variable from the string. Okay, a question is, can you commit this? Let me just commit this for you. I'm committing in the GitHub repository in Scala. Git add, what is the 7th April, right? So here, git commit 7 April messages binary search. Okay, and then I'm going to push it. So I added, committed, and then I'm pushing it. I'm just hoping that it'll work. What happened to the console? Okay. Ouch. So I would not be able to push it. All right. So I'm not sure. So if I just go back, there was this. All right. So yes, you can ask me a question in the meantime. I'm just going back to my older repository and we'll commit from there. So yes, that's right. Thank you, Mama. So more or less, most of the algorithms that work on divide and conquer work on the same complexity. All right. So let me just go to Scala folder and here. Okay, so I'm going to just move my file from there to here, from the big data, Scala, and 7 April, and then git add 7 April, git, I hope this works, push. Okay, so git commit, added 7 April, and then git push. All right, so I shouldn't have deleted this since it has some bugs. All right, so let me just reload this and that'll make more sense too. I'll just stop my running once and we'll let it restart. Okay, which commands are you talking about, David? The commit commands? I can definitely do that. So actually, these commands are not useful for you. The one that we have used here, I'll just explain if you want. But these are basically, since I'm trying to commit to the repository, that's why. These are basically for my own use. Okay, and so basically what I did was I did git pull, git as a git add, commit, and push. These are the things that I did. And then I realized that, okay, my older repository, I had set up the proper login and permissions. So I moved to the older repository and then I did the pull there and then added the same file, what I did in the previous repository and did that. Okay, so yeah, that's what I did. So do you want this whole thing? This is my command history. Without the numbers in the first line, you could try that. Okay, remove, these are the line numbers. You could always take a look at your history by using the history command on the console. That helps you to find. All right, so wonderful. And right, so there are a few very important things that we learned as part of this discussion, because those are the things that matter a lot. Okay, so what we just learned was that the binary search, like the one that you see here, this one basically takes exactly like log n time, because every time we are having, we are converting our total list to search into half. We are slicing the overall search space to half. Okay, that means that as we have, that means that it'll take log n time to find, right? The time complexity of this program is same as the time complexity of this program. I'll just delete this part. Okay, this one, right? The time complexity of this one is same as this one because we are making half every time. All right, so basically when you create indexes, you basically bring down the time to log n, and that changes everything. So now I hope this makes sense to you, this expression. All right, let's move on now. Okay, now the next important thing that I want to discuss is the functions. So functions are basically the true representative of a computer, right? A computer has input, it gives output. Similarly, functions take input optionally and gives you the output. All right. So function is basically the bunch of statements which you are creating a module out of it. So sometimes functions are also called modules. Sometimes functions are also called sometimes you call functions as methods and so on. So there are quite a few terminology for this. So here is a simplest definition of a function. So I'm calling it add nums, right? Just to keep it very clear that it is our function. Now, let us say you need to very often add two numbers, right? You would like to create your own library function just like the way we have been using library functions earlier. So in that case, you will basically use this kind of syntax. You will say def space followed by the name of the function, whatever you wish to define, then first argument, then second argument, and then return a value. Okay, this is the return data type. This is the data type of y. This is the data type of x, and then you return a value. Okay, so let me just define it and call it here itself, or just first define it here and say add nums. Okay, and say 6 plus 7, and let me define it where x equals this, and I'm just printing x. Okay, so you can see that it is working perfectly fine. Now this function I could use inside loops. Also something that seemed very obvious to us, but for the beginners in the coding, that you could define anything inside anything. So a while loop can have another while loop, it could have another expression, it could have another condition. So there could be all kinds of scenarios. You can have if condition inside a while loop, while condition inside of if loop, while condition, while loop inside a if condition, and so on. So you have all the combinations possible. And in the similar way, you could also use loops inside functions, and you could call the functions inside the loops. Okay, so that way basically you have the complete flexibility of calling the function anywhere. You can define the function once and use it anywhere. Okay, so it becomes like a bunch of code that you have kept it somewhere aside, and you're calling it again and again. So you could call it on any kind of values. Okay, you could call it on any kind of values, right? And get the answer. Okay, if you try to call it, okay, you can see that. A question from David is, are there procedures also? No, this is what we call procedures. Okay, so function can act like a procedure. So function, procedures, methods, or sometimes we call them modules also in some languages. Okay, so it's the same thing. So we define functions, though there is another abstraction thing that we'll talk about called a data structure called class, like when we want to create custom data types. Okay, A question from Sachin is, what is the complexity of this function? Very good question. Complexity of this function, we call it O1, right? It's a constant time. It is, right? If there are, if how big is the value doesn't matter. We are going to get only the single statement. Okay, so the time taken to run this statement is independent of how big x or y is. Therefore, we call it O1. All right, great question. And right, this is an interesting question. So wonderful, right? So and this is a good thing because right, that clears. These are the good example that we must look for. What happened to this guy? Just close it. Okay. I'll just refresh it. I think it just needs a bit of refresh. Hi, everyone. Are you able to hear me? Okay. Let it load. I'm just waiting for it to load. Okay. Looks like he is super busy. Oh, finally it came. I actually even open F for that matter. All right. So great. Great. Now, we were talking about functions, so we are able to see that. And did a lot of code got deleted? All right. So the complexity of this is O1, right? That's what we talked extra, and we also ran one more statement. All right. Now moving ahead. Now there is an interesting part. So we can actually define the function, right? Like this one, we could actually define a binary search. So we could just take this piece of code, okay, and put it inside a function, okay? We could say define binary search, okay? And the argument that we are going to use is one is list, other is one is list, other is what do you say, target, correct? That's all. Right, so we have just and one more thing we need to do is we need to return a value. We need to return a value, so we can return found. Okay, we could return found, and also we don't need to check this condition if found is matched or not. We could just remove these parts because we could here say return mid. That's all. Okay, that's all. So all we need to do is basically return the value. And here in the last, we just say return -1. Okay. So list here, we'll just say it's of type list, and we are further passing the integer. And okay, so what happened here? Define. Okay, this is how it needs to give. It needs to give. All right. So I hope that's clear now. So we're defining a really complex function right away. We're defining a really complex function right away. So exactly the way we did the define of this function, we did a complex function here to do the binary search. We just wrapped it in this, all the piece of code, we just put it inside. The elements that we had, target and list index, okay, or list, actually, it's using list, not list index. Okay, so it's actually list that's using. So good. Now that also makes it very clear. So you can see that we just defined a function. All right. We just defined a function here, and we are calling this binary search on our list. Okay, what was the list? Here was the list. Okay, let's see if it works. And we are calling this binary search on the list index, comma, the target. Okay, so it is found at this location. Does it make sense to you? So this is the, so we generally call it refactoring, that we had this function and the everything was in the main code. We took the code and created a function out of it. That's called refactoring. So this binary search takes list as argument, target as argument, meaning find this target in this list and return some value. Return some value. Okay, that's all. All right. So this was a little complex example. Now further to our function definition, to the same function what we did earlier, the addition function, right? The addition function that we were doing here, we can actually just return nothing. Okay, we can just return nothing. So return type is basically nothing here. So we can use like print ln like this. Okay. So you can see that we don't have to explicitly define even the return type all the time. It automatically figured out from the last statement. Last statement in the function, like in even above, we could do the same thing. We could remove this return type. Okay. And okay. So I think when you are having this kind of model, we need to define that. So it's not mandatory to put return on the last statement. If your last statement is the return value, then you just let it be. Okay. And if I'm just wondering, can I just do this and return here like this, and then delete this also. I'm just experimenting with this one. So I think no, actually. So we will have to have the okay, so we'll have to have the return type. So if we don't need, if our statement in the function is the last statement, then it is considered as the return value. Okay. So question from Alok is, how will we know the function is return value or not if we do not have access code of the function? If we do not have if you do not have access to the code, right? That's right. So basically it automatically infers the data type from the last line, and When we are importing the function, it will automatically show you that this particular function has this return type. Okay. So while it compiles the code, it basically infers that at the compile time. All right. So it's similar to you typing it there. Instead, the compiler does it for you. A question from Raju is, what is the unit keyword used in function? When we want to return anything from the function, then we generally put unit. We'll talk about it. All right. So I hope the function definition is clear. Then here is further abbreviation to the function. So this definition of function was little too big. So and we very often need to define functions anonymously, and that's where we could basically define a function like this. Okay, so the same function, the one that we are doing here, taking two arguments x and y and returning x plus y, the same function can be abbreviated into a single expression. All right, so you can actually define the function like this. So let me just wait. Oh, it's not running, so I'll have to restart the kernel. All right, let me refresh it. All right. So in the similar way, we have just defined our addition function, add 4, 5. So it is working fine. You can see that this is how we can define really quickly the function. Let's say we want to define our own function called square, right? Our own function called square. So we could just say square, right? And say x into x. And then use this square function. Okay, use this square function like that. Use the tab to autocomplete. Okay, so all right. So this way we could always do the do this, create our function very quickly. All right. So further to the discussion on Scala, let's talk about a few more things which are really important. So while talking about loops earlier, when we were talking about for loop, we talked briefly about list. So list, as well as we did 1 to 10, that was the range, right? So all of these things are data structures. List, range, all of these things are data structures, or you can say collections, collection of multiple primitive values. Okay, so collections are very important when it comes to the creating your logic, creating any kind of combining multiple values together. So collections are really useful. So collections provide different ways to store data. Scala collections hierarchy represents a structure of collections that can contain data in different ways. Okay, so in Scala, you have various classes, like there is something called indexes sequence, linear sequence, sorted sequence, and bit set, sorted map, and so on. So sorted map is kind of a map is a kind of iterable over which you can iterate, and iterable is kind of the top level class called traversable. Okay, we will talk about the inheritance hierarchy. For now, understand that the Scala provides you a lot of powerful collections using which you could create many kind of applications. Say, for example, you want to do word count, or you want to create your own dictionary. What is the property of a dictionary? Dictionary is a very, very useful thing in which you could very quickly retrieve a value for a key, right? So the most so that kind of a dictionary, if you have to implement, you can simply use a map. Okay, if you have a list of things, then you can use set. If you just want to iterate over things, called sequence, and so on, right? So traversable is the top level hierarchy functionality that is being implemented by all of these. All of these are something over which you could traverse. Okay, traversable and iterable are very similar things, just that iterable is basically one level more than traversable. Okay. So the most common one that we have already used is the sequence. Sequence is an ordered collection of data, may be or may not be indexed. Okay, indexed here is different from what we studied earlier. That indexing was kind of sorting. Here indexing means we are marking them with a location like 0, 1, 2. That's the index positions. Okay, so some of the sequences could be just list of things and there's no way to access them, and some of them which are derived data types could be index. Say for example, we have array, list, and vector. These are the three different classes which are inheriting the sequence. So the first one is an array. Array contains data of the same type. Array is fixed size and is ordered sequence of data. Array is an ordered sequence of data. Values are stored in values in the system's memory are stored in contiguous way, as in a sequential way. Okay, so array is fixed size and is ordered. It orders basically list of things in the memory, and these are indexed by positions, right? Let's take a look. All right, what is the bit set? Bit set is basically a set in which the values are bit. Okay, values are bit, which are really efficient for implementing various kinds of searches, such as Bloom filters. Okay, we'll talk about those very soon. Now, coming back to where we were, so these are the languages. You see, the languages is a variable containing an array which has these three values: Ruby, SQL, and Python. Okay, now we can access it using languages like this, right? You can using the index. You notice that unlike C or Java or Python, the instead of square brackets, it is the round brackets. Okay, so this way you can access the particular value from the array, right? You could say 1 and access SQL. Notice that 0 means the first value. 0 means Ruby, 1 means SQL, and 2 means Python. Okay, so you notice that this is indexed from 0. We call it 0 base index. Okay, a question from Binta is collection a constructor of the is collection a constructor of data, not data type conception? Collection is basically separate kind of a collection is basically separate class or separate object, and in which you could put other objects. Okay, so using collections, we could keep things in them. Okay, in which are very useful way of keeping things, right? We're keeping primitive objects or the advanced objects. So to create your custom object, like the way we have integer, string, if you want to create your own, we create using classes. If you want to gather, if you want to do some kind of manipulation of data on a larger scale, we generally use collections to keep things in certain order. Is it like compiled? No, no, anything can be kept in the collection. Anything can be. Like here we are keeping Ruby, SQL, these are strings that we're keeping. Collections, it's an array is a collection. Array is a collection. List is a collection. We'll talk about. A question is how many data types in Scala and what are they? So the basic data type that we have studied, one is integer, Boolean, and string, and the other ones like float and character. So those are the basic ones. And then you can extend them or import other classes and have more data types. All right. So that way. So great. Now moving ahead, now if you want to, let's say, change the particular value, we can change that particular value. So you can see we have changed languages, the first element in the languages from SQL to C++. Okay, just for showing that we can change the values in an array. Array could have numbers, array could have strings, array could have anything in them. Just that all the values of array must be of same data types. All right. Also, please note that we can iterate over an array. We can iterate over an array. So we could say we could iterate over an array really easily. Right? So when we say traversable, this is what it means by traversable. Any data type that is traversable can be used in the loop. Okay? This is what it means by traversable. Another question from Hitendra is, question is, array is mutable? Yes, you can modify. Mutable means something that can be changed. An array can be changed. All right. Also, if there are like syntax, like we could say languages colon plus, and we could add things like Scala colon plus right Scala, right? That means we are adding this languages with a new value, but it will basically return a newer variable, right? It will return a newer variable, and the older variable will remain as such, while newer value will have this. So if you want to append something to the languages, it'll return a newer array which will have these. So the array is a fixed size one. When we are appending something to an array, it is going to recreate the whole array at a new place. Okay. So I think that answers. A question from Grishma is that what exactly does it mean? It means this is, this essentially under the hood, it is basically doing this. Okay, if I have to do the same thing, this is exactly doing this way. It's saying index equal. Okay, this is actually equal to saying for I equals 0 and x. Okay, x equals, or you can say x equals languages I. This is how I would write in Java if I have to do, or something like similar. So this symbol that you see, it's a special construct which signifies that we want to. It's a part of the for loop construct. Okay, it's a part of for loop construct. Okay, and yeah. So here, notice the one more construct saying colon plus is generally used in the sense of when we want to append something to something. Okay, most of the data structures of Python, of Scala, they support colon plus, right? And that's actually the way it is. So colon plus is something that is it will be found in other data structures also. Okay, now there is something called list. List represents linked list. How many of you know what is linked list? The array cannot be extended. If you want to extend array, the entire array will be relocated to a newer location. Okay, but a list is something that is linked list, meaning what's a linked list? Internally, the data is kept in this form. Like this is one value, this is another value, this is third value. Okay, and internally, this one is keeping a link to the next one. Okay, this one is keeping the here every of these records have the pointers, right? So if we are saying A equals list 1, 2, 3, and 4. So internally, you can think of this as like we have 4 boxes. We have 4 boxes. Let me just draw one more box somewhere. Okay, it has 4 boxes. All right, it has 4 boxes, and in this 1 is capped, in this 2 is capped, in this 3 is capped, and in this 4 is capped, right? And this one contains the address of this one. This is the address. This one contains the address of the next one, and this one contains the address of the next one. So linked list is this. Linked list means basically it's a list of things internally which are linked, meaning that they don't have to be continuous. So if we had an array, let's say we had a B equals array 3, 4, 5, right? So in the memory, it'll be basically continuous. It'll be continuous, something like this, okay? And there will be more values. So there'll be like 3, 4, 5, 6, and so on. If we had like, if we had 6 also here, right? So basically here, the good part was it does not, right? Here the array is internally it is stored like this, which means there's no extra space that is gone in the list for the pointer. Here there's an extra space that has gone for the pointer. Okay, so this one is right, this is how it is. So basically the in the array, in case you want to change it, it'll be relocated. If you want to extend the number of values, then it'll be relocated to another space in the memory. Okay, so the list could be, the data could be anywhere in the memory because it keeps that, and therefore generally list is less performant than array. Okay, so question from Sachin is how we can implement doubly, singly, and circular linked lists in Scala. You can create your own classes that we will talk about soon. Okay, although a lot of constructs are provided by these ones. Okay, question from David is list an array. So list is something that is located in anywhere in the memory. So I'll just describe. So we can infinitely keep adding values to the list. Okay, because this data could be anywhere in the memory. So we don't require a big block of space available for us in the memory. Some data could be here, some data could be anywhere. If you think of a memory of the computer like a big wall in which there are bricks, so bricks of data that we keep. So those bricks could be anywhere on that wall, right? But in case of array, whatever array we are defining, that much space we need in a single sort, right? That's why array is difficult to allocate if you have low memory in the computer. So it'll take time to find out that place where that much size is available upfront, okay, and so on. All right. So therefore, that's a big difference between array and list. Okay, list of values or array of values. Array, all of the values will be contiguous in the memory, and the list would be anywhere. Just that it can be anywhere because it maintains the pointer. This one takes around twice the time, takes around 1.5 times or twice the storage, because it has to store one more pointer. Pointer is nothing but number, and that number means the address of this location. Okay. A question from Minta is, what is the difference between array, list, map, dictionary, tuple in Java, Python, Scala, and R? All right. So that would be a big comprehensive question. Okay. I think we can take it up towards the end, because this is a big question and it deserves more attention. Okay, more details actually. All right, I'll just keep it there. Great, great. Did I miss some more questions? All right. So David, was I able to answer your question? David, was he? Okay. All right. So great. We'll be also ending in 4 minutes. All right. So a question from David is, does array needs contiguous memory while linked list does not? Perfect. That's right. I missed that point. And question from Hiten, somewhere I read the list is immutable. Is that right? Actually, most of these data structures are immutable, immutable. But you have corresponding data type called mutable, a parallel collection in Scala, which you can just import and use them. All right. So Scala has created two set of collections. One is set of immutable and others are mutable. Okay, we'll talk about those soon. So theoretically, list is unbounded in the size, right? So let's take a look at some of the lists. Okay, here this is our list, and we can add let's say 4 to it. So we have just added 4 to the list. Okay, but the actual list will still remain till the 3, because it has created a new pointer there, and so. Okay, so here it is, and yes. So basically, we could access the elements just like we accessed in array. Like if you want to access the 0th element, that will be 1, right? And 2, as well as we could iterate over, say, a list exactly the same way. We could iterate over the list exactly the same way, and we could say print ln. Okay, so we could iterate exactly the same way the way we did in array. We can access the elements, we can append the elements to it, and so on. Okay. All right. So a question from Mohammed is, why would you need colon plus as opposed to just plus? Because that would not work out, because it say that it is trying to add 2 integers. Okay, or just plus. Okay, it says type mismatch. Therefore, to append, it's generally colon plus everywhere in the Scala. Just like plus plus is there in most of the languages, or plus equals to is there to increment a value of something. Similarly, here there is colon plus to increase the value, appends a value to a list. Okay, so a question from Grishma, is it like list can be traversed on both sides? It's preferred over arrays on some scenarios. So basically list is preferred only in the cases where we don't know upfront how many elements are we going to have. That's the only advantage of the list. Arrays are good if we have a relatively static data and we are not changing or increasing the size of arrays. Okay, so in those cases we prefer arrays, and if we are going to increase more and more values of list, then you better use list instead of array. Question from Midda is, are there some collections specifically available for Scala, Python, Java, and R, and why? So good. So every collection that is defined as part of Java is available in Scala. Every collection that was part of Java is available in Scala. Why? Because every class of Java can be used in Scala. All right. So, but most of these libraries like Scala, Python, Java, and R, all of them have rich set of data structures and rich set of collections. All of them. A question from Raju, is list and Scala collections are heterogeneous or homogeneous? So list and array collections. So it depends on which collection are we using. The list and array are homogeneous, meaning all the elements in an array or a list have to be of the same data type. Okay, while in case of other collections, you could have different types. All right, you could always say unit and you keep anything in that. Okay, is my voice gone? Let me just check if it is coming through headphone. All right, so I think we'll continue from here tomorrow at the same time. All right, we'll continue from here tomorrow. It's 11 p.m. I look forward to see you tomorrow at the same time. Thank you, everyone. All right. Thank you, everyone. I look forward to see you. Bye-bye. Have a good day.